Now let's talk about molecular formulas. The molecular formula provides the actual number of atoms of each element in a compound, which can be different from the empirical formula. Here is what you need to know. The molecular formula shows the actual number of each type of atom in a molecule of a compound. For example, the molecular formula of benzene is 66H6, which means each molecule of benzene contains 6 carbon atoms and 6 hydrogen atoms. Now, how do we determine molecular formula? Step 1. Find the empirical formula as we did earlier. Step 2. Determine the molar mass of the empirical formula. Step 3. Divide the molar mass of the compound by the empirical formula mass to find the multiplier n. And step 4. Multiply the subscript in the empirical formula by n to get the molecular formula. So calculation under this topic will be done in our next video. Now that we have covered both formulas, let's summarize the key differences between empirical and molecular formula. Empirical formula represents the simplest ratio of atoms. For example, for hydrogen peroxide, which is H2O2, the empirical formula is HO. While molecular formula represents the actual number of atoms in a molecule. For example, the molecular formula of hydrogen peroxide is H2O2. Some compounds have the same empirical formula and molecular formula. For example, C has both formulas as C, which is carbon. Today, we have talked about differences between empirical formula and molecular formulas and learn how to determine each. Understanding this formula is essential for chemists as they provide insight into the composition of substances and their properties. Thanks for joining me. Bye.